Welcome back. Our last video here on exponential properties is talking about negative exponents, and this might have come to your brain immediately when we talked about this property here. Because there's subtraction involved, if the denominator has a larger exponent, then you would have a negative exponent when you subtract them. And so that's going to be the example here. So let's look. X to the fourth divided by x to the fifth in this first example. So if I was to, we're going to look at two ways, similar to how we looked at the x to the 0 case. One way is let's just use what we know about exponents and kind of figure things out. Scratch that, actually. Let's start with their properties. So we know if I have x to the fourth divided by x to the fifth, and they're the same base. That, again, that's really, really important to make sure they have the same base. In this case, the base is both x. So we're going to take a look at, let's see, x to the fourth divided by x to the fifth would just be x to the 4 minus 5. Well, 4 minus 5 is equal to negative 1. And therefore, this is really just equal to x to the negative 1 power. Great. And that's totally legit. You know, if you take a mathematician and give them, hey, x to the negative 1, they actually know what you're talking about. This is what they'll, this is what they will do. This is what they'll have in their mind. Is that let's think about breaking this up like we did previously. And what I mean by that is I have x to the fourth right here on top. In the numerator, in the denominator, I have 4 x's, but there's 1 left over. And so I multiply this by 1 over x. All right, so on top, there's just 4 x's. In the bottom, there's 5. And so there would be 1 left over in the bottom. And so really, this x to the fourth divided by x to the fourth, that'd just be a big old 1. And you're really just left with 1 over x. So actually, x to the negative 1 is equal to 1 over x. Let's take a look at one more example and see if we can kind of generalize this. Now I have x to the 7th over x to the 10th. So using our property, we will subtract them. And so we'll have x to the 7 minus 10, or x to the negative 3. Or we could look at it like so, group up 7 of the x's, and I'd be left with 3 more x's in the denominator. Therefore, I have a giant 1 right there, and I'm left with 1 over, I'm left with 1 over x cubed. So x to the negative 3 is equal to 1 over x cubed. And there you have it. So what's going on here? Well, notice I can actually see the negative 3, and the connection here is that there's a positive 3 exponent right there. But what happened? When I started off with x to the negative 3, when that exponent turned positive, that value, that x, the base, went to the denominator now of the fraction. Likewise, if I take a look at this first one, x to the negative 1, this one's weird because you don't see the 1, but actually, remember that x is equal to just x to the first power. Just like how 2 to the 1 is really just 2, 3 to the 1 is really just 3, and so on. And so in general, this is definitely one we're going to want to put in our toolbox as well, is that x to the negative a power, a could be, negative 7, or sorry, it could be, negative 7, negative 8, whatever, is really just equal to 1 over x to the positive a. Right? And again, that one might be tricky to remember, but we don't need to memorize or remember it if we just remember how exponents work. In that I remember, hey, I can group them up and evaluate and simplify and then get our final simplified expression. I have a third example here because this is a type of problem that comes up that throws people off. And what happens when the negative exponent is already in the denominator? So let's kind of cut this one off here. Let's look at that. Well, The way, and here's how I would recommend doing it, and you might have another way to look at it, and that's totally fine. But this is how I look at it, is that for right now, I'm going to cover up the numerator for now. Well, in my mind, so this is Mr. Chang right here, right? I got my glasses on, right? That's me. In my speech bubble, or my thought bubble here, I am already thinking, well, let's see. I know that y to the negative 2 on its own in a vacuum, oops, is equal to 1 over y squared. Let me write that a little neater, excuse me. 1 over y squared, right? I already know that. Well, let's now substitute that in. And so really, 1 over y to the negative 2 is equal to 1 over, and this looks kind of funky, but it's 1 over itself. There's a fraction itself in the denominator. 1 divided by this value. And I'll put it in parentheses so we don't so we can kind of keep track of what's going on. So 1 over y to the negative 2 is really 1 over y squared. Now, this looks nasty, and usually we don't like to look at what we call compound fractions, fractions within fractions. But if we just remember how fractions work and what they are, this is actually not too bad. Because, remember, every fraction is a division problem in itself. So 1/2, for example, is really just 1 divided by 2, or 0.5. And so really, this is equal to 1 divided by 1 over y squared. If you remember how to multiply and divide fractions, really this just means 1 times its reciprocal, y squared over 1. And hey, 1 times anything is just the thing itself. It really just comes down to y squared. And that is our final simplified expression right there. Okay, and so the way some people kind of think about this is that when you have a negative exponent, you just flip it to the other side, either from the numerator to denominator or denominator to numerator, and then change its sign from positive to negative or vice versa. But this is an explanation as to why that works. Okay, hopefully this made some sense, and now you can tackle any type of exponential simplification problem. Alrighty, so thanks for watching our snippet on exponents and their properties and simplifying expressions. Stay spicy, folks. I'll see you in the next one.